everyone, welcome to my channel. I am your two-man Dong Dashui. Today I will talk to you about the common temperature instruments in chemical production. Temperature is one of the most common and basic parameters in chemical process operations, and the vast majority of chemical or physical changes in the production process are related to temperature, so temperature measurement is particularly important. The temperature scale is the standard system for measuring temperature. It is similar to a ruler of temperature, and the common temperature scales are the Celsius, Fahrenheit, and Kelvin temperature scales. The Celsius temperature scale of 0度 is defined as the freezing point of water, and 100度 is defined as the boiling point of water, which is the most commonly used temperature scale worldwide. The Fahrenheit scale of 32度 is defined as the freezing point of water, and 212度 is defined as the boiling point of water. It is more used in Western countries. The Kelvin temperature scale is the international temperature scale, and 0 Kelvin is defined as absolute zero, at which point all thermal motion stops. The Kelvin temperature scale is often used in scientific research, especially in the field of astrophysics. Common temperature measurement methods in production are divided into contact thermometry and non-contact thermometry. The contact thermometry method is simple and reliable, with high measurement accuracy, but at the same time, it may react with the measured object due to contact with the measured object and sufficient heat exchange. Moreover, due to the limitations of high-temperature materials, contact meters cannot be used for extremely high-temperature measurements. Commonly used contact temperature measuring instruments mainly include thermal expansion thermometers, thermocouples, and thermal resistance thermometers. Thermal expansion thermometers are made according to the principle of thermal expansion of objects, and the common ones are bimetal disc thermometers, glass liquid thermometers, and pressure thermometers. For example, the mercury thermometer and the alcohol thermometer that we usually use to measure body temperature are glass liquid thermometers. It is made by filling a capillary tube inside a graduated glass rod with a working liquid. The liquid column rises due to the increase in temperature and volume expansion of the working liquid, which indicates the corresponding temperature value. The structure is simple and easy to use, but the material is easy to be damaged, and the data is not convenient to transmit remotely. Pressure thermometers also use the principle of heating and expansion of working liquids or gases, store them in the instrument, and combine the temperature pack with a spring tube. When the working fluid inside the chamber is heated after expansion, the spring tube is driven to deform to indicate the temperature. The interior is similar to that of a spring tube pressure gauge. The overall structure is simple, the measurement range is wide, the temperature sensing is relatively sensitive, the accuracy is moderate, and the price will be slightly higher. A bimetal thermometer is a thermometer that works by using the difference in expansion of different materials, and bimetal can be seen on many components that control temperature. It is made of pressing two pieces of metal with a large difference in thermal expansion coefficient, and when the bimetal sheet is heated and heated, the metal sheet bends to the side with a small expansion coefficient when the tightening combination cannot be layered. Depending on the temperature, the curvature also changes. The thermometer makes a spiral of a bimetal plate, and when the temperature rises, the metal plate rotates to drive the dial to rotate at a corresponding angle. The overall structure is simple. The environment is adaptable, cheap and durable. Overall, thermostatic thermometers are simple in structure, low in cost, do not require a power supply, and have moderate accuracy. It is commonly used in routine in situ applications. With the improvement of chemical automation requirements, there is more need for remote transmission and centralized control of equipment parameters, and the coverage of integrated transmitters such as thermocouples and thermal resistance that are convenient for remote signal transmission is increasing year by year. Thermocouple thermometer is one of the most widely used temperature measuring instruments at this stage. It has a wide temperature measurement range, high upper limit, fast response, high accuracy, and the signal is easy to transmit remotely. Its working principle is based on the thermoelectric effect, and the main components are two metal wires of different materials, which are welded together at the temperature measurement end and the hot end. When the temperature changes, an electromotive force will be generated between two metal wires of different materials in the circuit at the ambient end and the cold end, so that a certain amount of current will be generated in the whole circuit. This electric type is proportional to the temperature difference, which calculates the temperature at the measuring end. Thermoelectromotive force is composed of the contact electromotive force of two conductors and the temperature difference electric force of a single conductor. Thermocouples can be selected to use metal wires as required, measuring a wide range of temperatures, from ultra-low temperatures to very high temperatures. The use of fort covers and color clothing can work stably in harsh environments such as high temperature, high pressure, and corrosiveness. The integrated thermocouple transmission feeds according to the ambient temperature of the cold, and the temperature is compensated, and the electrical signal that can be transmitted remotely is given after calculation, and the accuracy is high. The design principle of RTD thermometer is to take advantage of the property that the resistance value of some materials changes with the change of temperature, and the metal material is generally called thermal resistance, and the semiconductor material is called thermistor. In general, the resistance value of a metal increases nearly linearly with increasing temperature, and the temperature to be measured can be determined by measuring the resistance value of the RTD. The measurement range of RTD thermometer is usually low and medium temperature. The signal can be transmitted remotely. The response is sensitive. There is no ambient temperature limit. The work is stable, and the accuracy is high, but the measurement process needs to provide power supply, and the cost is slightly higher. The structure of industrial RTD is sleeved type and modified type. The casing type is made by assembling the pattern sensing element and the lead wire in a closed bunker sleeve at one end, and then installing the wiring together. The color-mounted type is a combination of temperature sensing elements and lead insulation, and then stretched into a solid hole by the mold, which has the characteristics of solid, shock-resistant, bendable wear diameter, and easy to use. Non-contact temperature measuring instrument. Because the measuring element is not in direct contact with the measured substance, will not interfere with the measured object, will not be affected by the measured object. the measurement range is large, the temperature measurement speed is fast, and it can also be measured in motion. However, it is affected by the emissivity of the measured object itself and other measurement media, and the temperature measurement accuracy is not enough, and the error is large, because the temperature measurement is achieved by measuring the radiant energy of the object or the signal related to the radiant energy. It is also called a radiant temperature measuring instrument. Any object whose temperature exceeds absolute zero radiates energy to its surroundings in the form of electromagnetic waves. Measuring the radiation intensity of an object at a certain wavelength can deduce its temperature, which is the basic principle of temperature measurement with radiative thermometers. Radiometric thermometry is commonly used as a luminance thermometer that measures the radiant brightness of a target. A total radiation thermometer that measures temperature by measuring the total radiant energy emitted by an object. 3. A colorimetric thermometer that compares the energy of the filter with a similar wavelength band. The radiation temperature measurement method is widely used in the measurement of high temperature areas above 900 摄氏度. In daily work, it is non-contact for the normal temperature range. Infrared thermometers are the most widely used for temperature measurement. The infrared thermometer can generally measure the temperature in the range of -50 到500度, which is very convenient for daily measurement. However, it should be noted that if it is used for surface measurement of shiny metals, the error will be large. Transparent objects such as glass and acrylic, steam, smoke, etc., cannot be penetrated during temperature measurement, which will affect the accuracy of the measurement. There are many types of temperature instruments, and only by understanding the characteristics and differences of various types can we better select and use them in production. The above is all the content of today's video.